The universe is hiding secrets that could rewrite everything we know, and today we're uncovering 30 of them. Picture this: black holes drifting alone like cosmic nomads, planets where it rains diamonds, and radio signals from distant stars that might not be natural at all. These aren't scenes from a sci-fi movie. They're real discoveries shaking the foundations of astronomy. From rogue black holes tearing through our galaxy to ancient galaxies defying the laws of physics, space is stranger than we ever imagined. And the best part, scientists are just scratching the surface. Stick around, because by the end of this journey, you'll see the cosmos in a whole new light. Ready to dive into the mysteries that could change everything? Let's go. Now, let's turn our attention to a cosmic loner that's rewriting the rules of black hole behavior. For the first time ever, astronomers have spotted a rogue black hole drifting through the Milky Way, completely untethered from any star or galaxy. This isn't just a rare sight, it's a discovery that flips our understanding of how black holes form and move through space. Most black holes we know about are part of binary systems, orbiting stars or lurking at the centers of galaxies. But this one is different. It's traveling solo, invisible except for the way its gravity bends the light of stars behind it, a phenomenon called microlensing. Scientists estimate it weighs around 7 times the mass of our Sun, and it's moving at a staggering speed of 160,000 kilometers per hour. What makes this rogue black hole so groundbreaking? For starters, it challenges the idea that black holes are always tied to their stellar origins. Its existence suggests that many more of these lone wanderers could be out there, undetected, reshaping our galaxy in ways we're only beginning to grasp. Some theories even propose that rogue black holes could be remnants of the universe's earliest days, flung into space by violent cosmic events. But here's the real kicker. If there are more of these invisible drifters, they could be silently influencing star formation, warping space-time, and even posing unseen hazards to anything that crosses their path. This discovery doesn't just add a new chapter to black hole science, it forces us to rethink how these mysterious objects shape the cosmos. And if this is just the first one we've found, imagine what else might be lurking in the dark. Now, shifting our gaze closer to home, let's talk about a discovery that sent shockwaves through the scientific community: the detection of phosphine gas in Venus's atmosphere. This wasn't just another chemical finding, it was a potential hint of life on our neighboring planet, sparking debates that are still raging today. Phosphine is a simple molecule, just one phosphorus atom bonded to 3 hydrogen atoms, but here's why it's so intriguing. On Earth, phosphine is almost exclusively produced by living organisms, like microbes in oxygen-free environments or industrially in labs. It's not something you'd expect to find floating around in a planet's atmosphere without a biological source. So when astronomers spotted its spectral signature in Venus's clouds, the immediate question was, could this mean there's life there? Venus, with its crushing surface pressure, scorching temperatures hot enough to melt lead, and clouds of sulfuric acid, seems like the last place you'd look for life. But the detection of phosphine in its cooler upper cloud layers, where conditions are less extreme, opened up a tantalizing possibility. Maybe, just maybe, microbial life could be floating high above the planet's hellish surface, surviving in droplets of water and using phosphine as a byproduct of their metabolism. Of course, not everyone was convinced. The discovery ignited a firestorm of skepticism. Some scientists argued that the phosphine signal could be a false positive, or that non-biological processes like volcanic activity or unknown chemical reactions could explain its presence. Others pointed out that Venus's harsh environment makes even the hardiest Earth microbes seem fragile by comparison. The debate became so intense that teams around the world rushed to reanalyze the data, and follow-up observations have yet to definitively confirm or refute the original findings. What makes this discovery so revolutionary isn't just the possibility of life. it's the way it forces us to reconsider where life could exist. If phosphine on Venus really is a biosignature, it means life might thrive in places we once thought impossible. And if it's not, the hunt for its origin could uncover entirely new planetary chemistry. Either way, this discovery has turned Venus from a forgotten sibling of Earth into one of the most exciting frontiers in astrobiology. The conversation is far from over, and that's what makes science so thrilling. Now, let's turn our attention to a discovery that brings the cosmos a little closer to home water on the Moon's sunlit surface. For decades, scientists believed water could only exist in the Moon's permanently shadowed craters, where temperatures stay frigid enough to preserve ice. But in 2020, NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA, made a game-changing detection: water molecules clinging to sunlit lunar soil. This wasn't just a trace amount. The data revealed water concentrations of up to 400 parts per million in the Moon's southern hemisphere. That's roughly equivalent to a 12-ounce bottle of water spread across a cubic meter of soil. It might not sound like much, but for future lunar explorers, it's a potential gold mine. Water isn't just for drinking, it can be split into hydrogen and oxygen for rocket fuel or breathable air, turning the Moon into a cosmic gas station for deeper space missions. The real puzzle is how this water survives at all. Sunlit lunar surfaces reach temperatures hot enough to boil water away, so how is it sticking around? One theory suggests tiny glass beads formed by micrometeorite impacts might trap water molecules inside, shielding them from the sun's heat. Another possibility is that the Moon's soil has a special way of holding onto water at a molecular level. Whatever the explanation, this discovery rewrites our understanding of the Moon's chemistry. The technology behind this breakthrough is just as fascinating. SOFIA, a modified Boeing 747 jet with a massive infrared telescope, flew at altitudes of over 40,000 feet to peer at the Moon's surface. At that height, above most of Earth's water vapor, its instruments could detect the unique infrared signature of water molecules without interference. It's a reminder that sometimes the best way to study space is by looking from the edge of our own atmosphere. This finding doesn't just hint at a more resource-rich Moon, it opens the door to sustainable lunar bases. Imagine astronauts harvesting water directly from the soil, reducing the need to launch heavy supplies from Earth. It's a critical step toward making the Moon a stepping stone for Mars and beyond. And with NASA's Artemis program aiming to return humans to the lunar surface, this discovery couldn't have come at a better time. The Moon, it turns out, might be far more than a dry, dusty rock. It could be the key to humanity's future in space. But just when we thought the Moon had given us its biggest surprise, the cosmos delivered another head-scratcher, this time from our very own stellar backyard. In 2020, astronomers detected a bizarre radio signal coming from Proxima Centauri, the closest star system to our Sun. At first glance, this signal, dubbed BLC-1, seemed almost too perfect. It was a narrow-band radio wave, precisely the kind of transmission we'd expect from an intelligent source, and it appeared to originate from the direction of Proxima Centauri b, a potentially habitable exoplanet. The signal even drifted slightly in frequency, mimicking what you'd see if it were coming from a planet moving around its star. Naturally, the discovery sparked wild speculation. Could this be our first real evidence of alien technology? Scientists quickly pointed out that while the signal was intriguing, it wasn't definitive proof. For one, it only appeared once during 30 hours of observations, and follow-up searches failed to detect it again. Then there's the fact that Proxima Centauri is a flare star, prone to violent outbursts that could mimic artificial signals. But here's where it gets even weirder. The signal's frequency, around 980 MHz, is suspiciously quiet, a range where human-made interference is rare. It's also a frequency that spacecraft often use, leading some to wonder if it could have been a stray transmission from a passing satellite. Yet no known human technology matched the signal's peculiar characteristics. So what's the most plausible explanation? Most astronomers lean toward a natural origin, perhaps an unusually powerful stellar flare or an undiscovered type of radio burst. But the possibility of an artificial source, however slim, keeps the debate alive. After all, Proxima Centauri b sits in the habitable zone where liquid water could exist. If there's even a remote chance of life there, this signal, whether a cosmic coincidence or something more, reminds us that the universe still has plenty of mysteries left to solve. And while we may never know the true nature of BLC-1, its discovery has already changed the game. It's sharpened our methods for detecting potential alien signals and proven that even our closest stellar neighbor can still surprise us. The search continues, and who knows, the next signal might not be so ambiguous. Now, let's shift our gaze from mysterious signals to something even more mind-bending, a structure so vast it challenges everything we thought we knew about the universe. Meet the Giant Arc, a colossal arrangement of galaxies stretching an astonishing 3.3 billion light-years across. To put that in perspective, if you could travel at the speed of light, it would take you more than 3 billion years just to go from one end to the other. This discovery, made by astronomers analyzing light from distant quasars, completely upends the cosmological principle, the long-held assumption that matter in the universe is evenly distributed on the largest scales. Instead, the Giant Arc reveals a universe with unexpected wrinkles, where galaxies cluster in patterns far grander than anyone predicted. What makes this arc so extraordinary isn't just its size, but what it implies. According to our current models, structures this massive simply shouldn't exist. The Big Bang's afterglow suggests a relatively smooth distribution of matter, yet here we have a galactic ribbon defying the odds. Some scientists argue it could hint at flaws in our understanding of gravity or even the nature of dark matter. Others propose it might be a statistical fluke, though the odds of that are astronomically low. One thing's for certain: the Giant Arc forces us to reconsider the universe's architecture. If such enormous structures are possible, what else might be lurking in the cosmic shadows? Could there be even larger formations waiting to be discovered? Every time we think we've grasped the universe's blueprint, it throws us a curveball, reminding us that the cosmos still has plenty of surprises up its sleeve. And as telescopes grow more powerful, who knows what other colossal mysteries we'll uncover next? Now, let's turn our attention from vast cosmic structures to something equally mind-blowing, a black hole with an appetite so fierce it's rewriting the rules of astrophysics. Meet the fastest-growing black hole ever discovered, a cosmic monster consuming the equivalent of an entire sun's mass every single day. That's right, every 24 hours, this behemoth devours a star's worth of material, making it the hungriest object we've ever observed in the universe. This black hole, officially known as J2157, isn't just breaking records, it's shattering them. With a mass roughly 34 billion times that of our Sun, it's one of the most massive black holes ever found. But what truly sets it apart is its staggering growth rate. To put it in perspective, if our own Milky Way supermassive black hole grew at this rate, it would swallow 2/3 of all the stars in our galaxy. So how does something like this even form? Scientists believe J2157 offers a rare glimpse into the early universe, a time when conditions were perfect for black holes to balloon to unimaginable sizes. Back then, the cosmos was smaller and denser, packed with gas and dust that fed these growing giants. This black hole's extreme appetite suggests it's been feasting non-stop for billions of years, giving us clues about how the universe's first supermassive black holes came to be. But here's the real kicker. J2157 is also one of the brightest objects in the universe. As it devours matter, the material heats up and emits blinding radiation, outshining entire galaxies. This makes it a quasar, a type of active galactic nucleus that acts like a cosmic lighthouse, visible across mind-bending distances. What does this mean for our understanding of the cosmos? For starters, J2157 challenges our models of black hole growth. We used to think there was a limit to how fast these objects could expand, but this discovery proves otherwise. It also raises tantalizing questions. Could there be even larger, faster-growing black holes lurking in the universe's darkest corners? And what does this tell us about the chaotic, high-energy conditions of the early universe? One thing's clear: the more we learn about black holes like J2157, the more we realize how much we still don't know. These cosmic titans continue to push the boundaries of physics, forcing us to rethink our theories and stay humble in the face of the universe's endless mysteries. And with next-generation telescopes coming online, who knows what other record-breaking monsters we'll uncover next? Shifting our gaze from the ravenous black holes of deep space, let's land right here in our own cosmic backyard, Mars. The Red Planet has just handed us one of its most tantalizing secrets yet. Thanks to NASA's Perseverance rover, we've uncovered complex organic molecules in Jezero Crater, a site that was once a sprawling lake billions of years ago. These aren't just any molecules, they're the kind that, on Earth, are often associated with life. Now, before we jump to conclusions, let's clarify what this means. Organic molecules are carbon-based compounds, the building blocks of life as we know it, but they can also form through non-biological processes like chemical reactions in rocks or even delivery by meteorites. What makes this discovery so electrifying is the context. Jezero Crater was carefully chosen as Perseverance's landing site precisely because its ancient river delta and lakebed sediments are prime real estate for preserving signs of past life. Finding these molecules here, nestled in rocks that once interacted with liquid water, cranks up the intrigue to new heights. Perseverance didn't just stumble upon these compounds, it hunted them down with Sherlock, an instrument that scans rocks with ultraviolet lasers to map out organic material. The rover found aromatic molecules like benzene, along with sulfates, which on Earth often form in environments where microbes thrive. Together, these clues paint a picture of a once habitable Mars, where the ingredients for life were not just present but possibly abundant. So, does this mean we've found evidence of Martian life? Not yet. But it's the strongest hint so far that Mars had, or maybe even still has, the right conditions for it. Think of it like finding a wet towel in a desert. It doesn't prove someone's there, but it sure suggests they might have been recently. The next step, Perseverance is already collecting samples for a future mission to bring back to Earth, where labs can analyze them with far more precision. If those samples contain biosignatures, actual traces of past life, it would rewrite humanity's understanding of our place in the cosmos. Until then, this discovery fuels the fire of possibility, reminding us that Mars still has stories left to tell. And who knows, the Red Planet's biggest revelation might be just a drill sample away. Now, let's journey from the dusty plains of Mars to a galaxy that defies everything we thought we knew about the cosmos. Meet NGC 1052DF2, a galaxy that's turning heads for all the wrong reasons, or maybe all the right ones. This strange, ghostly galaxy appears to be missing something crucial: dark matter. And that's a big deal because, according to our current understanding, dark matter is the invisible glue that holds galaxies together. Imagine building a house without a foundation. That's essentially what this galaxy seems to have done. Dark matter makes up about 85% of the universe's mass, and its gravitational pull is what keeps stars from flying apart as galaxies spin. But when astronomers studied NGC 1052DF2, they found something bizarre. The stars inside it were moving so slowly that there simply wasn't enough gravity to hold them together unless, of course, dark matter wasn't there at all. This discovery sent shockwaves through the scientific community because it challenges two fundamental ideas. First, it questions how galaxies form. If dark matter isn't always necessary, then our models of galaxy birth might need a serious rewrite. Second, it puts a spotlight on gravity itself. Could there be something wrong with our understanding of how gravity works on cosmic scales? Some scientists have even suggested alternative theories like modified Newtonian dynamics to explain this oddity. So how did this galaxy end up so empty? One theory is that it was once part of a larger galaxy cluster, and violent interactions stripped away its dark matter, leaving behind a skeleton of stars. Another possibility, it formed in a way we've never seen before, without dark matter playing its usual role. Either way, NGC 1052DF2 is forcing us to rethink the rules of the universe. What's next? Astronomers are now hunting for more of these dark matter-deficient galaxies to see if this is a cosmic fluke or a sign of something deeper. Every new discovery like this peels back another layer of the universe's mysteries, reminding us that space still has plenty of surprises up its sleeve. And who knows, the next galaxy we study might just shatter another piece of what we thought we knew. Now, let's turn our attention from galaxies missing dark matter to an object that raced through our solar system, leaving scientists scratching their heads. Meet Oumuamua, the first known visitor from interstellar space. This strange, elongated object didn't just pass by. It accelerated in a way that defied simple explanation, sparking debates that range from the mundane to the extraordinary. When Oumuamua was first spotted in 2017, it was already speeding away from the Sun. But instead of slowing down as expected, it picked up speed as if pushed by an unseen force. Normally, comets exhibit similar behavior when sunlight vaporizes their icy surfaces, creating a gas tail that acts like a natural thruster. But Oumuamua showed no signs of outgassing, no visible tail, no cloud of dust or gas. So what was propelling it? One leading theory suggests that Oumuamua might have been releasing hydrogen gas trapped beneath its surface. Unlike water ice, hydrogen is invisible to telescopes, which could explain why we didn't see any outgassing. As the sun's heat warmed the object, the hydrogen could have escaped, giving it a subtle but measurable push. This would make Oumuamua a cosmic iceberg of sorts, a relic from another star system with a composition unlike anything in our solar system. But not everyone is convinced. Some researchers have proposed even wilder ideas, like the possibility that Oumuamua was an artificial object, a solar sail or probe sent by an advanced civilization. While this theory is far from mainstream, it highlights just how baffling this interstellar visitor truly is. After all, if natural explanations fall short, shouldn't we at least consider the extraordinary? The truth is, we may never know for sure. Oumuamua is now too far away to observe further, leaving its mysteries unresolved. But its brief visit taught us something invaluable. Interstellar objects are real, and they might not behave the way we expect. Future telescopes like the Vera Rubin Observatory could spot more of these visitors, helping us piece together the puzzle. Until then, Oumuamua remains a tantalizing reminder that the universe is full of surprises, some of which might be sailing right through our cosmic backyard. Shifting our gaze from mysterious interstellar visitors, let's dive into one of cosmology's biggest puzzles, the case of the universe's missing matter. For decades, scientists knew the universe contained far less visible matter than their calculations predicted. Where was it hiding? The answer turned out to be hiding in plain sight, woven into the fabric of the cosmos itself. The missing matter isn't dark matter, that's a separate enigma. This was ordinary baryonic matter, the stuff that makes up stars, planets, and us. Based on the afterglow of the Big Bang, researchers estimated how much of this normal matter should exist. Yet when they tallied up all the galaxies, gas, and dust they could see, nearly half of it was unaccounted for. It was like misplacing the keys to the universe and searching for them for 30 years. Then, in a breakthrough, astronomers finally spotted the missing matter, not in galaxies, but in the vast, faint threads of gas stretching between them. These cosmic filaments, part of the so-called cosmic web, are so diffuse they're nearly invisible. But by studying how light from distant quasars filtered through these tendrils, scientists detected the faint glow of ionized oxygen, revealing the hidden matter at last. This discovery didn't just solve a cosmic accounting error. It confirmed a fundamental prediction about how the universe is structured. Simulations had long suggested that most ordinary matter would be scattered in these intergalactic threads, but proving it required painstaking observation. Now, with the mystery resolved, we have a clearer picture of how matter is distributed across the universe, from the densest galaxies to the emptiest voids. So why does this matter? Because it's a reminder that even the most elusive pieces of the cosmic puzzle eventually fall into place. And with each mystery solved, we get one step closer to understanding the grand tapestry of the universe thread by thread. Turning our attention to the ancient past, let's journey to the edges of time itself with the discovery of the oldest spiral galaxy ever found. Meet BRI 13350417, a stunning cosmic whirlpool that existed when the universe was just 1.4 billion years old, a mere toddler by cosmic standards. What makes this galaxy extraordinary isn't just its age, but its shape. Spiral galaxies like our Milky Way were thought to take billions of years to form their elegant arms, yet here's BRI 13350417, already fully formed when the universe was barely 10% of its current age. This discovery turns previous theories on their head. Astronomers once believed such intricate structures required long, slow processes, gas clouds gradually collapsing, stars forming in waves, and gravitational dances shaping the arms over eons. But BRI 13350417 suggests otherwise. Its existence implies that spiral galaxies could assemble far quicker than anyone imagined, possibly through violent mergers or intense bursts of star formation in the early universe's chaotic environment. Peering at this galaxy is like uncovering a fossil from the cosmic dawn. Using the Atacama Large Millimeter Array, scientists detected its spiral arms through faint radio waves emitted by dust and gas. The galaxy's sheer size, spanning tens of thousands of light-years, hints at a voracious appetite, devouring surrounding material to fuel its rapid growth. Why does this rewrite of galactic history matter? Because it forces us to reconsider how structure emerges in the universe. If spirals could form this early, other assumptions about galaxy evolution might need revisiting too. BRI 13350417 isn't just a relic, it's a clue whispering secrets about how order arose from the primordial chaos of the young cosmos. And with each clue, we inch closer to understanding how galaxies, including our own, came to be. Now let's shift our gaze to a world that defies expectations. A planet so strange it wears its atmosphere like a comet's tail. Meet GJ 436b, an exoplanet that's literally leaving a trail across the cosmos. Unlike any planet in our solar system, this Neptune-sized world orbits perilously close to its star, and the intense heat is tearing its atmosphere apart, creating a colossal hydrogen tail stretching over 3 million miles. What makes GJ 436b so fascinating isn't just its dramatic appearance, but what it reveals about the fragility of planetary atmospheres. Imagine a world where the stellar winds are so fierce they strip away gas molecules, sending them streaming into space like smoke from a candle. That's exactly what's happening here. Scientists first spotted this eerie tail using ultraviolet telescopes, which detected the faint glow of hydrogen gas being ripped away from the planet's outer layers. This isn't just a cosmic spectacle, it's a clue to how planets evolve under extreme conditions. GJ436b's tail suggests that even large, gaseous worlds can lose their atmospheres over time, especially in harsh environments near their stars. Some researchers think this process might explain why we find so few Neptune-sized planets in tight orbits. They could be shrinking into smaller, rocky cores as their atmospheres evaporate. But here's the twist: GJ436b's tail isn't uniform. It's patchy and irregular, hinting at turbulent interactions between the planet's magnetic field and the stellar wind. This messy escape act challenges our models of atmospheric loss, showing that the process is far more complex than a simple, steady leak. By studying this bizarre world, astronomers are piecing together the fate of planets in extreme environments. GJ436b isn't just a curiosity. It's a window into the violent processes that shape planetary systems, reminding us that even in the vastness of space, nothing lasts forever. And as we uncover more about these alien worlds, we're learning just how diverse and unpredictable the universe can be. Now, let's turn our attention to a planet that shatters everything we thought we knew about rocky worlds. Meet Kepler-10c, a colossal enigma nicknamed the Mega-Earth. This planet isn't just big, it's a heavyweight champion, tipping the scales at nearly 17 times the mass of our own Earth. But here's the real shocker: despite its immense size, it's not a gas giant. Instead, it's a dense, rocky behemoth, defying the very models scientists used to explain how planets form. For years, astronomers assumed that planets this massive would inevitably accumulate thick hydrogen atmospheres, becoming mini Neptunes or gas giants. But Kepler-10c laughs in the face of those assumptions. Its sheer density suggests a composition of rock and metal with no substantial gas envelope. That discovery sent shockwaves through the planetary science community, forcing a rethink of how rocky planets can grow. What's even more intriguing is where this planet lies. It orbits perilously close to its star, completing a full revolution in just 45 days. Conventional wisdom said such a scorching environment would strip away any chance of habitability. But Kepler-10c's existence expands the concept of the habitable zone. If a rocky planet can be this massive and still hold onto its structure under extreme conditions, it opens the door to the possibility of other mega-Earths in more temperate orbits, worlds that might just have the right conditions for life. The discovery also raises tantalizing questions about planetary formation. How did Kepler-10c accumulate so much rock without becoming a gas giant? Some theories suggest it might have formed farther out in its system, where icy materials were abundant before migrating inward. Others propose it could be the remnant core of a failed gas giant, its atmosphere boiled away by stellar radiation. Whatever its origins, Kepler-10c is a game-changer. It proves the universe is far more creative than our textbooks, crafting planets that defy expectations. And as we keep searching, who knows what other rocky giants might be waiting in the cosmic dark worlds that could rewrite the rules of where life might thrive. Now, let's pull back the curtain on one of the universe's most elusive structures, the cosmic web. Picture an enormous, invisible network stretching across the cosmos, connecting galaxies like threads in a vast tapestry. But here's the twist. Scientists have just detected something woven into those threads that no one expected: magnetic fields. For decades, the cosmic web was thought to be shaped by gravity alone, with galaxies clustering along filaments of dark matter. But recent breakthroughs revealed something far more intricate. Using radio telescopes, researchers spotted faint magnetic fields threading through these cosmic highways, the first direct evidence of their existence in the web's largest structures. These fields are weak, about 1 million times fainter than Earth's magnetic field, but their presence is a game changer. So why does this matter? Magnetic fields are like invisible sculptors, influencing how gas flows, how stars form, and even how galaxies evolve. They can accelerate particles to near light speeds, shape the birth of new stars, and potentially steer entire galaxies along the web's filaments. Before this discovery, no one knew these forces played a role on such a colossal scale. Now we're seeing the cosmic web not just as a scaffold for galaxies, but as a dynamic system buzzing with unseen energy. The big question is, where did these magnetic fields come from? One theory suggests they were seeded in the early universe, amplified over billions of years by the motion of gas and galaxies. Another idea points to supermassive black holes whose jets might have injected magnetic energy into the web. Whatever their origin, their detection opens a new window into understanding how the universe's largest structures grow and change. This discovery doesn't just add a layer to our cosmic maps, it rewrites the rules of the game. Magnetic fields are now part of the story of how galaxies are born, live, and die. And as we keep probing deeper, who knows what other invisible forces might be hiding in the dark, shaping the universe in ways we're only beginning to imagine. Now, let's turn our attention to a signal from the depths of space that has left scientists utterly baffled. A fast radio burst with a pattern. Fast radio bursts, or FRB, are already some of the most mysterious phenomena in the universe. Blasts of radio waves that last just milliseconds but pack the energy of hundreds of millions of suns. But this one, known as FRB 180916, is different. It doesn't just fire off randomly, it repeats in a precise 157-day cycle like clockwork. Imagine picking up a signal from a galaxy over 500 million light-years away and realizing it's pulsing on a schedule. For 70 days, it's silent. Then for the next 90 days, it erupts in bursts every few hours, then silence again. This isn't just a cosmic fluke, it's a pattern, and patterns in nature usually mean something. So what's causing it? One leading theory points to neutron stars, the dense remnants of exploded stars. Some neutron stars, called magnetars, have incredibly strong magnetic fields that could produce these bursts. If this one is wobbling or interacting with another object, like a companion star, it might explain the cycle. But here's the twist: no known neutron star behaves quite like this. The timing is too precise, too predictable. Then there's the more speculative idea: alien megastructures. Could this be some kind of beacon or even an interstellar communication attempt? While it's a tantalizing thought, scientists urge caution. The universe is full of natural phenomena we don't yet understand, and jumping to extraterrestrial conclusions isn't helpful. But the fact that the possibility even crosses our minds shows just how strange this signal is. Another hypothesis suggests the bursts could be coming from a black hole's accretion disk, where swirling debris creates periodic shocks. Or perhaps it's a cosmic lighthouse effect, with a neutron star's beam sweeping past us at regular intervals. Whatever the answer, this FRB is forcing us to rethink what we know about these extreme cosmic events. What makes this discovery so thrilling isn't just the mystery, it's the potential. If we can crack the code of this repeating signal, we might unlock new physics or even new ways to map the universe. For now, it remains one of space's most intriguing puzzles, a reminder that the cosmos still has plenty of surprises up its sleeve. Now, let's shift our gaze to a cosmic heavyweight that defies expectations. The so-called impossible neutron star, J0740+6620. This celestial titan isn't just another dense remnant of a supernova, it's pushing the very boundaries of what we thought possible for a neutron star. Neutron stars are already mind-bending objects, packing more mass than our Sun into a sphere no wider than a city. But J0740+6620 takes it to another level. Clocking in at around 2.14 times the Sun's mass, it's one of the heaviest neutron stars ever discovered. And here's the kicker: it's teetering right on the edge of becoming a black hole. According to our current understanding of physics, once a neutron star crosses a certain mass threshold, it should collapse under its own gravity, vanishing into a black hole. But this star isn't just flirting with that limit, it's dancing on it. Scientists are scrambling to figure out how it's holding itself together. Does it have an exotic internal structure we don't yet understand? Could unknown forces be at play, keeping it from tipping over the edge? One theory suggests that the star's core might be made up of strange quarks, particles even more exotic than the usual protons and neutrons. If true, this would rewrite the rules of how matter behaves under extreme pressure. Another idea is that our models of neutron star interiors are incomplete, and there's a hidden mechanism preventing collapse. What makes this discovery so groundbreaking isn't just the star itself. It's what it tells us about the universe's most extreme environments. By studying J0740 plus 6620, we're not just testing the limits of stars, we're testing the limits of physics itself. If neutron stars can exist this close to black hole territory, it forces us to rethink everything from gravity to the nature of matter. For now, this cosmic heavyweight remains a tantalizing mystery, a reminder that even the most established laws of physics might have exceptions waiting to be uncovered. And as we keep searching, who knows what other impossibilities we might find lurking in the depths of space. Now, let's journey to the outer reaches of our solar system, where Neptune hides one of the most dazzling secrets in the cosmos: diamond rain. Yes, you heard that right. On this distant ice giant, scientists believe it literally rains diamonds, and this isn't just science fiction. It's been confirmed in groundbreaking lab experiments. Picture this, deep within Neptune's atmosphere, where pressures are millions of times stronger than on Earth, and temperatures soar to thousands of degrees, something extraordinary happens. Methane, a common gas in Neptune's composition, gets crushed under these extreme conditions. The carbon atoms inside methane break free, then bond together under immense pressure, forming solid diamonds. These diamonds don't just sit there, they fall like glittering raindrops through the planet's dense layers, sinking toward the core. How do we know this happens? Scientists recreated Neptune's extreme environment in labs here on Earth, using powerful lasers to simulate the crushing pressures inside the planet. In these experiments, they watched as carbon transformed into tiny diamonds right before their eyes. This discovery doesn't just add a touch of cosmic glamour, it reshapes our understanding of planetary interiors. Diamond rain could explain why Neptune radiates more heat than it receives from the sun. As diamonds sink, they generate friction, releasing energy that warms the planet from within. This process might also occur on other ice giants like Uranus, hinting that diamond precipitation could be a common phenomenon in our galaxy. Beyond its sheer spectacle, this discovery has real-world implications. Understanding how materials behave under such extreme conditions helps us model the formation of planets, both in our solar system and beyond. It even opens doors for new materials science here on Earth, where lab-grown diamonds could have futuristic applications. So next time you look up at Neptune, remember beneath its serene blue exterior lies a storm of diamonds, a reminder that the universe is far stranger and more wondrous than we ever imagined. And who knows, maybe one day we'll find a way to study this glittering phenomenon up close. Now, let's turn our attention to one of the most elusive cosmic mysteries, the ghostly dark galaxy Antlia II. This nearly invisible giant has baffled astronomers since its discovery, not because of what it shows, but because of what it doesn't. Unlike typical galaxies, Antlia II is almost entirely made of dark matter, the mysterious substance that makes up most of the universe's mass but refuses to interact with light. Imagine a galaxy so faint that it blends into the darkness of space, hiding in plain sight. Antlia II is roughly the size of our Milky Way, but its stars are spread so thinly that it emits barely any light. In fact, it's 100 times dimmer than other galaxies of its size. That's why it took so long for astronomers to spot it, even though it's been lurking right in our cosmic backyard, orbiting the Milky Way. So how did we finally detect this shadowy giant? Researchers used data from the Gaia Space Telescope, which maps the positions and movements of stars with incredible precision. They noticed a strange wobble in the motion of certain stars, a gravitational tug that couldn't be explained by visible matter alone. That's when they realized something massive but invisible was pulling on those stars. That something was Antlia 2, a galaxy dominated by dark matter. This discovery challenges our understanding of how galaxies form. Most galaxies, like our own, have a balance of dark matter and visible stars. But Antlia 2 defies that norm, with dark matter making up nearly all its mass. Scientists think it might be a relic from the early universe, a surviving fragment of a time when dark matter clumped together in ways we don't yet fully understand. What's even more intriguing is that Antlia 2's existence hints at the possibility of many more dark galaxies hiding in the cosmos, undetected because they don't glow. Finding them could help solve one of astronomy's biggest puzzles, the true nature of dark matter. So while Antlia 2 might be a ghost in the cosmic night, its discovery shines a light on the hidden architecture of the universe, reminding us that sometimes the most important things are the ones we can't even see. Now, shifting our gaze to another cosmic oddity, let's explore the fascinating case of twin stars with identical planets. Picture this, a binary star system where both stars aren't just siblings in space, but also share nearly identical exoplanets orbiting them. This discovery throws a wrench into our understanding of how planets form, especially in the chaotic environment of a dual star system. Typically, binary stars create a gravitational tug of war, making planet formation a messy and unpredictable process. But in this system, astronomers found something extraordinary: planets around each star that are eerily similar in size, composition, and even orbital distance. It's like nature copied and pasted the same planet around both stars, defying the odds. How could this happen? One theory suggests that these planets formed from the same disk of gas and dust that once surrounded both stars, emerging under nearly identical conditions. Another possibility is that the planets migrated inward or outward in sync, maintaining their similarities over billions of years. Either way, this discovery challenges the idea that binary systems produce wildly different planetary outcomes. What makes this even more intriguing is the implication for habitable worlds. If planets can form so similarly in such systems, could there be twin Earths orbiting twin suns? It's a tantalizing thought, opening new doors in the search for life beyond our solar system. This discovery doesn't just add another layer to the mystery of planetary formation, it forces us to rethink the rules entirely. And if twin stars can host twin planets, who knows what other cosmic duplicates might be waiting to be found? Now, let's dive into something that sounds almost like science fiction: a black hole ringing like a bell. Scientists have detected gravitational wave echoes from a black hole, marking the first time we've directly observed its post-merger vibrations. Imagine the aftermath of two black holes colliding, sending ripples through space-time itself. But instead of fading into silence, the newly formed black hole continues to vibrate, producing a faint but detectable hum. These vibrations, or ringing, are caused by the black hole settling into its final shape after the violent merger. Think of it like striking a bell. The initial impact creates a loud sound, but the bell keeps ringing at specific tones as it settles. Similarly, the black hole emits gravitational waves at distinct frequencies, revealing its mass and spin. What's groundbreaking here is that these echoes match predictions from Einstein's theory of general relativity with stunning precision, giving us a new way to test the limits of physics. But why does this matter? These vibrations act like a cosmic fingerprint, helping scientists understand black holes in ways never before possible. By studying the ringing, researchers can probe the very nature of space-time near a black hole's event horizon, where gravity is so intense that even light can't escape. Some even speculate that these echoes could hint at quantum effects or hidden structures near black holes, opening doors to entirely new physics. This discovery isn't just about confirming what we already know, it's about uncovering what we don't. If black holes can ring like bells, what other secrets might their echoes reveal? The universe just got a little louder, and we're finally learning how to listen. Now, let's turn our attention from the echoes of black holes to something much closer to home, right under our feet, or rather, under the moon's surface. Hidden beneath the lunar landscape lies a network of enormous tunnels, carved out by ancient lava flows billions of years ago. These aren't just small cracks, they're massive, habitable-sized passageways, some large enough to fit entire cities inside. What makes these lava tubes so special? For starters, they're nature's perfect bunkers. The moon's surface is bombarded by radiation and micrometeorites, making it a harsh environment for human explorers. But these underground tunnels offer natural shielding, protecting future astronauts from these dangers. Imagine setting up a lunar base inside one of these tubes. It's like having a ready-made fortress, complete with a thick ceiling of solid rock. Scientists have spotted these tubes using radar and gravity measurements, revealing entrances called skylights where the roofs of the tunnels have collapsed. Some of these openings lead to caverns stretching for miles, with stable temperatures and potential access to water ice trapped in the shadows. That means not only shelter but also resources for sustaining life. The implications are huge. If we're serious about establishing a long-term presence on the moon, these lava tubes could be the key. They'd reduce the need to build everything from scratch, saving time, money, and risk. Plus, they could serve as stepping stones for deeper space exploration, offering a safe haven for missions to Mars and beyond. So while black holes ring in the depths of space, the moon whispers secrets of its own hidden tunnels that might just become humanity's first off-world homes. The cosmos isn't just out there, it's right beneath us, waiting to be explored. But now, let's journey from the moon's hidden tunnels to a cosmic oddity so strange it defies everything we thought we knew about galaxies. Meet AGC 229385, a galaxy that's almost completely empty, no stars, no glowing gas, just an eerie void. Yet somehow it's still a galaxy. How? Because this ghostly structure is packed with something invisible and mysterious, dark matter. This isn't just a faint or dim galaxy, it's a cosmic rebel. Most galaxies, like our Milky Way, are dazzling cities of stars held together by dark matter. But AGC 229385 flips the script. It's a sprawling metropolis where the streets are empty, where dark matter isn't just the scaffolding, it's practically the entire building. Scientists stumbled upon it by accident, noticing its gravitational pull on nearby objects despite having almost no visible material. What makes this discovery so mind-bending? It forces us to rethink what a galaxy even is. If a collection of stars isn't required, then our definition might be too narrow. Could there be countless other dark matter galaxies lurking unseen, weaving through the cosmos like invisible threads? Some researchers think so, and AGC 229385 might be the first of many. Theories about how this galaxy formed are just as puzzling. Maybe it's a failed galaxy, one that never quite gathered enough gas to birth stars. Or perhaps it's the remnant of a violent encounter, stripped of its stars by a larger neighbor. Either way, it's a cosmic riddle that reminds us how much we still don't understand about the universe's hidden architecture. So while we search for life in lunar lava tubes, the cosmos throws us another curveball, a galaxy that's all shadow, no light. It's a humbling reminder that even in the vastness of space, the most ordinary things can turn out to be the most extraordinary. Now, let's shift from the ghostly emptiness of dark matter galaxies to a world so extreme it feels like science fiction. Picture this, a planet where the skies aren't filled with water droplets but with vaporized metals, where it doesn't rain water but liquid rubies and sapphires. Welcome to WASP 121b, a hot Jupiter that redefines what we thought was possible in planetary atmospheres. This exoplanet orbits so close to its star that its dayside temperatures soar to a blistering 2,700 degrees Celsius, hot enough to vaporize iron and titanium. But here's where it gets wild. On the cooler night side, those vaporized metals condense into clouds, and when they rain down, they don't form ordinary metal droplets. Instead, they create liquid gemstones. Imagine a storm where the raindrops are literally made of ruby and sapphire. It's like something out of a cosmic jewelry store. Scientists first spotted this bizarre weather system using the Hubble Space Telescope, which detected the signatures of these metals in the planet's atmosphere. But WASP-121b isn't just a spectacle, it's a laboratory. By studying how metals behave under such extreme conditions, researchers are uncovering secrets about atmospheric chemistry that could apply to other exoplanets, even those in more temperate zones. What makes this discovery so groundbreaking? It challenges our assumptions about how planetary atmospheres work. We used to think gas giants like Jupiter were relatively uniform, but WASP-121b proves they can host chemistry as complex and exotic as any alien world from the movies. And if metals can rain as gems here, what other surreal weather might exist across the cosmos? So while dark matter galaxies remind us of the universe's hidden mysteries, WASP-121b shows us that even the visible cosmos still holds wonders beyond our wildest imagination. It's a dazzling reminder that the universe isn't just strange, it's downright extravagant. Now, let's turn our attention from the dazzling extravagance of gemstone rains to a cosmic puzzle that's keeping scientists up at night. The universe is expanding. We've known that for decades, but here's the twist. It's not expanding at the rate we thought. This mystery, known as the Hubble tension, is one of the biggest headaches in modern cosmology. Here's the problem. When scientists measure the universe's expansion rate using nearby galaxies and supernova, they get one number. But when they calculate it using the afterglow of the Big Bang, the cosmic microwave background, they get a different number. These two methods should agree, but they don't. And the gap between them isn't small, it's significant enough to suggest something fundamental is missing from our understanding of physics. What could explain this discrepancy? Some theorists think there might be unknown particles or forces at work, like a new type of dark energy that's speeding up the expansion in ways we don't yet grasp. Others wonder if dark matter behaves differently than we've assumed, or if gravity itself works differently on cosmic scales. Then there's the wilder possibility that our entire framework for the universe, from the Big Bang to dark energy, might need a major overhaul. The Hubble tension isn't just a technical disagreement, it's a potential crack in the foundation of modern cosmology. If it leads us to new physics, it could redefine everything we know about space, time, and the fate of the universe. And while we don't have answers yet, that's what makes this discovery so thrilling. It's a reminder that even our most trusted cosmic rules might still have surprises waiting to be uncovered. So while gemstone rains show us the universe's flair for the dramatic, the Hubble tension reveals something even more profound, that the cosmos still has secrets we're only beginning to unravel. But just when we think we've seen it all, the universe throws us another curveball. Let's talk about a star that refused to go quietly, supernova IPTF-14 HLS, the cosmic explosion that baffled astronomers by dying not once but multiple times over decades. This wasn't just any supernova. When it was first spotted in 2014, scientists expected it to fade away like every other stellar explosion. But instead of dimming, it flared up again and again, brightening and dimming at least 5 times over 600 days. And here's the real shocker. When researchers dug through old data, they found evidence that the same star had erupted way back in 1954. That's 60 years before its so-called final explosion. What could possibly cause a star to explode repeatedly? Current models of stellar death say this shouldn't happen. A supernova is supposed to be a star's last act, a one-time catastrophic event. But IPTF-14 HLS laughs in the face of those rules. Some theories suggest it might be a rare pulsational pair instability supernova, where a massive star becomes so unstable it undergoes violent eruptions before its core finally collapses. Others speculate it could involve a zombie star, a remnant that somehow reignites its nuclear furnace after a partial explosion. The mystery deepens when you consider the energy involved. IPTF-14 HLS released 10 times more energy than a typical supernova, yet its temperature stayed oddly constant. Even the debris around it moved slower than expected, as if the star was holding onto its material instead of blasting it into space. Every detail defies textbook explanations. This supernova challenges our most basic assumptions about how stars die. It's a reminder that the universe still has phenomena we can't yet explain, celestial enigmas that force us to rethink the rules. And as astronomers continue to study IPTF-14 HLS, one thing's certain: the cosmos has a flair for rewriting its own playbook when we least expect it. Now, let's shift our gaze to something equally mind-bending, a cosmic speedster defying all expectations. Meet the Cannonball Pulsar, officially known as J0002, a neutron star hurtling through space at a staggering 1,000 kilometers per second. To put that into perspective, that's fast enough to travel from Earth to the Moon in just under 7 minutes. This isn't just any runaway star. What makes J0002 extraordinary is the trail it left behind, a literal smoking gun. Astronomers discovered it racing away from the debris of its own supernova explosion, like a bullet fired from a cosmic rifle. The kicker: most neutron stars don't move this fast after a supernova. Typically, they're given a gentle nudge, but J0002 got a violent shove, launching it at 5 times the average speed of its kind. So how did this pulsar become such a cosmic outlier? The leading theory points to an asymmetrical explosion. When its parent star went supernova, the blast might have been lopsided, funneling energy in one direction like a rocket engine. That imbalance could have catapulted J0002 into its breakneck journey. Even more fascinating, the pulsar's path traces back directly to the heart of its former supernova remnant, CTB1, like a celestial breadcrumb trail leading home. But here's where it gets even wilder. J0002 isn't just fast, it's also spinning rapidly, completing a full rotation every 890 milliseconds. That dizzying spin, combined with its insane velocity, makes it one of the most extreme pulsars we've ever found. And because it's moving so quickly, it's destined to escape the Milky Way entirely, becoming a lone wanderer in intergalactic space. This discovery doesn't just add another oddball to the cosmic zoo. It gives us a rare glimpse into the chaotic aftermath of supernova, showing how these explosions can launch objects with unimaginable force. J0002 is a reminder that even in death, stars can go out with a bang, and sometimes that bang sends them flying across the universe. Now, let's turn our attention to a discovery that blurs the line between planet and moon, a cosmic first that has astronomers buzzing. Meet Kepler 1625b, the first strong candidate for an exomoon ever detected, and it's anything but ordinary. Picture a moon so massive it rivals the size of Neptune, orbiting a gas giant hundreds of light years away. This isn't just a moon, it's a world in its own right, challenging everything we thought we knew about how moons form and behave. Finding an exomoon is like spotting a firefly next to a spotlight. The methods astronomers used to detect Kepler 1625b are as ingenious as the discovery itself. They relied on 2 key techniques: the transit method and the transit timing variation method. When the gas giant Kepler 1625b passed in front of its star, it caused a predictable dip in starlight, but something peculiar happened. Just before and after the planet's transit, there were additional, smaller dips in brightness. That's the telltale signature of a moon trailing and leading its host planet like a cosmic shadow dance. The data also revealed another clue: a slight wobble in the planet's transit timing. This happens when the gravitational tug of a massive moon causes the planet to oscillate slightly, altering its orbit ever so subtly. Combine these two pieces of evidence and you've got a compelling case for an exomoon. But here's where the debate heats up. Some scientists argue the signals could be caused by other factors, like stellar activity or even a second planet in the system. The truth is, detecting something as faint and distant as an exomoon pushes our technology to its limits, making confirmation a painstaking process. What makes Kepler 1625b so fascinating isn't just its size, it's the implications. If confirmed, it would prove that moons can grow to planetary proportions, raising wild questions. Could such a moon host its own atmosphere or even liquid water? Could it be habitable? For now, the mystery lingers, but one thing's certain: this discovery opens a new frontier in our search for alien worlds. Moons, once afterthoughts in the cosmic hunt, might just be the next big thing in the quest for life beyond Earth. Now, let's journey even further back in time, to a galaxy that's like a living fossil from the universe's infancy. Meet DigiSat I, an ultra-pristine galaxy that's remained untouched by cosmic collisions for billions of years. Unlike most galaxies which grow and evolve through violent mergers, this rare relic has stayed eerily unchanged since the cosmic dawn, offering us an unprecedented glimpse into the early universe. What makes DigiSat I so special is its isolation. While other galaxies were busy crashing into each other, this one drifted alone, preserving its original structure and composition. Astronomers call it a ghost galaxy because of its faint, diffuse appearance, with stars spread so thinly that it's nearly transparent. Yet, its quiet existence holds explosive secrets. By studying its ancient stars and lack of heavy elements, scientists can piece together what the universe was like just a few 100 million years after the Big Bang. The discovery challenges our assumptions about how galaxies form. Most models suggest that early galaxies were small and chaotic, but DigiSat I's orderly, elongated shape defies expectations. Its stars move in slow, synchronized orbits, untouched by the gravitational turmoil that reshaped most of its peers. This raises a tantalizing question. Were there more of these pristine galaxies in the early universe, or is DigiSat I a cosmic fluke? For astronomers, it's like finding a perfectly preserved dinosaur bone in a world of fragments. Every detail, from its dim glow to its chemical makeup, acts as a time capsule, revealing conditions we've only theorized about. And as telescopes grow more powerful, we might uncover more of these fossils, rewriting the story of how galaxies began. One thing's clear: DigiSat I isn't just a galaxy. It's a portal to the past, waiting to show us how it all started. Now, let's take a leap from the ancient cosmos to the cutting edge of physics, where scientists are recreating black holes right here on Earth. In a groundbreaking experiment, researchers created a black hole analog in the lab, not with crushing gravity, but with supercooled quantum fluids. And what they found inside was astonishing: swirling quantum vortices that mimic the chaotic behavior around real black holes. These vortices are like tiny tornadoes in the fluid, spinning at incredible speeds and revealing secrets about how gravity and quantum mechanics might interact. Normally, these two fundamental forces don't play nicely together. Gravity shapes the universe on a grand scale, while quantum rules govern the subatomic world. But in these lab-made black holes, the vortices act as a bridge, showing how quantum effects could influence gravitational phenomena. The key to this discovery lies in the fluid's behavior. Just like matter spiraling into a black hole, particles in the fluid get dragged into the vortices, creating patterns eerily similar to what we'd expect near an actual event horizon. This gives physicists a safe, controlled way to test theories that would otherwise be impossible to study. For instance, it could help explain Stephen Hawking's famous prediction that black holes emit radiation, a quantum effect in a gravitational extreme. What's even more mind-bending is that these vortices might hint at a deeper connection between the very large and the very small. If quantum whirlpools can mimic black hole dynamics, it suggests that the universe's most mysterious forces might not be as separate as we once thought. This experiment doesn't just simulate a black hole. It opens a door to understanding how the fabric of reality might be woven together at its most fundamental level. As labs refine these simulations, we could be on the verge of solving one of physics' biggest puzzles, uniting gravity with quantum mechanics. And if that happens, it wouldn't just change our understanding of black holes, it would rewrite the rules of the universe itself. Now, let's turn our attention to one of the most intriguing what-ifs in modern physics, the white hole hypothesis. If black holes are cosmic vacuum cleaners, sucking in everything that crosses their path, white holes would be their exact opposites, spewing out matter and energy instead of trapping it. The idea might sound like science fiction, but it's rooted in the same equations that predict black holes. Einstein's theory of general relativity actually allows for the existence of white holes even if we've never observed one. Think of them as black holes running in reverse, where a black hole's event horizon is a point of no return. A white hole's would be a point of no entry. Nothing could get in, only out. Some scientists speculate that if a black hole collapses into a singularity, it might rebound as a white hole, effectively turning the end of one cosmic story into the beginning of another. One wild possibility is that the Big Bang itself could have been a white hole event, a sudden eruption of space-time and matter from an infinitely dense point. Others suggest that tiny white holes might explain mysterious bursts of energy in the universe, like certain types of gamma-ray explosions that don't quite fit our current models. Of course, the biggest challenge is finding evidence. Unlike black holes, which leave behind gravitational footprints and glowing accretion disks, white holes would be far more elusive. They'd theoretically emit energy but wouldn't interact with their surroundings in a way that's easy to detect. Some researchers propose that dark matter or unexplained cosmic rays could be signatures of white holes, but for now, these remain tantalizing guesses. What makes white holes so fascinating isn't just their strangeness, it's the way they force us to rethink the rules of the universe. If they exist, they could rewrite our understanding of time, causality, and even the birth of the cosmos. And if they don't, well, the fact that math allows them at all means there's still something profound we're missing about how reality works. Either way, the white hole hypothesis reminds us that the universe still has plenty of surprises left to reveal. And with that, we've journeyed through 30 of the most mind-bending discoveries in space, each one a puzzle piece that could reshape our understanding of the universe. From rogue black holes drifting through our galaxy to the eerie radio signals from Proxima Centauri, these findings don't just add to our knowledge, they challenge it. Imagine a cosmos where water hides in the moon's sunlight, where diamonds rain on Neptune, or where an entire galaxy defies the very idea of dark matter. These aren't just curiosities, they're clues that could rewrite the rules of physics, redefine life's potential beyond Earth, and even reveal the universe's best-kept secrets, like the missing matter finally found in cosmic filaments or the white holes that might lurk in the math of relativity. What ties them all together? The thrill of the unknown. Every discovery we've covered, whether it's the oldest spiral galaxy or the supernova that refused to die, proves that space still has endless surprises up its sleeve. And that's the beauty of science. Today's wild hypothesis could be tomorrow's textbook fact. So, what's next? That's up to you. Stay curious, keep looking up, and who knows, maybe you'll be the one to uncover the next cosmic game changer. If you enjoyed this journey through the universe's greatest mysteries, don't forget to hit like, subscribe, and ring that notification bell so you never miss out on the latest revelations. The cosmos is always evolving, and we're just getting started. Until next time, keep wondering, keep exploring, and remember, the universe has way more stories left to tell.